Hello everyone. So the question is a pendulum bob of mass 80 mg carrying a charge of 2 into 10 raised to power minus 8 coulomb is at rest in a uniform electric field of 20,000 volt per meter. Find the tension in the thread of the pendulum and it makes with the vertical. ਤਾਂ ਆਪਾਂ ਦੱਸਣਾ ਹੈਗਾ ਆਪਣੇ ਕੋਲ ਬੋਬ ਹੈ ਪੈਂਡੂਲਮ ਦਾ 80 mg ਦਾ ਤੇ ਉਸ ਤੇ ਚਾਰਜ ਹੈ 2 into 10 raised to power minus 8 ਕੂਲਮ ਤੇ ਉਹ ਰੈਸਟ ਤੇ ਹੈ ਤੇ ਇਲੈਕਟ੍ਰਿਕ ਫੀਲਡ ਆਪਾਂ ਹੌਰੀਜ਼ੌਂਟਲੀ ਲਗਾਈ ਹੋਈ ਹੈ ਜਿਸ ਦੀ ਵੈਲਿਊ 20,000 ਵੋਲਟ ਪਰ ਮੀਟਰ ਤੇ ਆਪਾਂ ਟੈਂਸ਼ਨ ਦੱਸਣੀ ਹੈ ਕਿੰਨੀ ਹੈ ਤੇ ਐਂਗਲ ਥੀਟਾ ਵਿਦ ਵਰਟੀਕਲ। ਤਾਂ ਆਪਾਂ ਹੁਣ ਕੁਐਸਚਨ ਸਟਾਰਟ ਕਰਦੇ ਹਾਂ। ਮੰਨ ਲਓ ਇਹ ਆਪਾਂ ਇੱਕ ਪੈਂਡੂਲਮ ਟਾਈਡ ਕੀਤਾ ਹੈ ਵਿਦ ਸੀਰੀ ਆ ਆਪਣਾ ਪੈਂਡੂਲਮ ਹੈ ਤੇ ਇਹਦਾ ਬੋਬ ਹੈ ਤੇ ਕਿਉਂਕਿ ਇਲੈਕਟ੍ਰਿਕ ਫੀਲਡ ਅਪਲਾਈ ਕੀਤੀ ਹੋਈ ਆਪਾਂ ਹੌਰੀਜ਼ੌਂਟਲ ਮੰਨ ਲਓ ਇਸ ਡਾਇਰੈਕਸ਼ਨ 'ਚ ਤਾਂ ਜਿਹੜਾ ਆਪਣਾ ਬੋਬ ਹੈ ਉਹ ਇੱਥੇ ਜਾ ਕੇ ਰੈਸਟ ਤੇ ਆ ਜਾਊਗਾ ਤੇ ਜਿਹੜਾ ਇਹਦਾ weight ਹੈ ਉਹ ਤਾਂ ਨੀਚੇ ਲੱਗ ਰਿਹਾ ਹੋਊਗਾ mg ਨੀਚੇ mg ਤੇ ਟੈਂਸ਼ਨ ਸਟ੍ਰਿੰਗ 'ਚ ਲੱਗ ਰਹੀ ਹੋਊਗੀ T ਤੇ ਆਪਾਂ ਇਸ ਟੈਂਸ਼ਨ ਦੇ ਜੇ ਆਪਾਂ ਦੋ ਕੰਪੋਨੈਂਟ ਕਰ ਦਈਏ ਮੰਨ ਲੈਣੇ ਆਪਣਾ ਐਂਗਲ ਥੀਟਾ ਹੈਗਾ ਤਾਂ ਕਿੰਨਾ ਹੋ ਗਿਆ ਆਪਣੇ ਕੋਲ ਟੈਂਸ਼ਨ ਦੇ ਜੇ ਆਪਾਂ ਕੰਪੋਨੈਂਟ ਕਰਦੇ ਹਾਂ T cos ਥੀਟਾ ਤੇ ਜੇ ਆਪਾਂ ਇੱਧਰ ਦੂਸਰਾ ਕੰਪੋਨੈਂਟ ਕਰਦੇ ਤਾਂ ਆਪਣਾ ਕੋਲ ਹੋਗਾ T sin ਥੀਟਾ। ਤਾਂ ਆਪਾਂ ਹੁਣ ਬੇਸਿਕਲੀ ਇਸ ਦਾ ਆਪਾਂ ਡਾਇਗਰਾਮ ਸਮਝ ਲਿਆ ਤੇ ਹੁਣ ਆਪਾਂ ਜਿਹੜੀ ਕੁਆਂਟੀਟੀਜ਼ ਆਪਾਂ ਨੂੰ ਗਿਵਨ ਹੈ ਕੁਐਸਚਨ 'ਚ ਆਪਾਂ ਉਹ ਲੈ ਲੈਣੇ ਆ। ਮਾਸ ਦੀ ਵੈਲਿਊ ਕਿੰਨੀ ਗਿਵਨ ਹੈਗੀ 80 mg ਤੇ ਆਪਾਂ ਨੂੰ ਚਾਰਜ ਕਿੰਨਾ ਗਿਵਨ ਹੈ 2 into 10 raised to power minus 8 ਕੂਲਮ ਤੇ ਇਲੈਕਟ੍ਰਿਕ ਫੀਲਡ ਦੀ ਵੈਲਿਊ ਕਿੰਨੀ ਗਿਵਨ ਹੈ 20,000 ਵੋਲਟ ਪਰ ਮੀਟਰ। ਤੇ ਹੁਣ ਆਪਾਂ ਜਿਹੜਾ ਮਾਸ ਹੈ ਇਹਨੂੰ ਆਪਾਂ ਪਹਿਲਾਂ kg 'ਚ ਕਨਵਰਟ ਕਰਦੇ ਹਾਂ 8 into 10 raised to power minus 6 kg। ਹੁਣ ਜਿਹੜਾ T cos ਥੀਟਾ ਕੰਪੋਨੈਂਟ ਹੈ ਇਹ mg ਨੂੰ ਬੈਲੈਂਸ ਕਰ ਰਿਹਾ ਹੈਗਾ ਤਾਂ ਆਪਾਂ ਕੀ ਲਿਖਦੇ ਹਾਂ ਇੱਥੇ T cos ਥੀਟਾ is equal to mg ਤੇ ਹੁਣ ਦੂਸਰੀ ਇਕੁਏਸ਼ਨ ਲਿਖਦੇ ਆਪਾਂ T sin ਥੀਟਾ is equal to Q into E। ਜਿਹੜੀ ਇਲੈਕਟ੍ਰਿਕ ਫੀਲਡ ਫੋਰਸ ਅਪਲਾਈ ਕਰੂਗੀ ਉਹ ਇਸ ਡਾਇਰੈਕਸ਼ਨ ਕਰੂਗੀ ਤੇ ਆਪਾਂ ਨੂੰ ਉਹਦਾ ਫੋਰਸ ਦੀ ਵੈਲਿਊ ਕਿੰਨੀ ਹੁੰਦੀ ਹੈ Q into E ਤੇ ਆਹ ਫੋਰਸ ਦੀ ਵੈਲਿਊ ਤੇ T sin ਥੀਟਾ ਇਕੁਅਲ ਹੋਣਗੇ। ਆਪਾਂ ਮੰਨ ਲੈਣੇ ਇਹਨੂੰ ਇਕੁਏਸ਼ਨ 1 ਮੰਨ ਲੈਣੇ ਤੇ ਇਹਨੂੰ ਇਕੁਏਸ਼ਨ 2 ਤਾਂ ਆਪਾਂ ਦੋਨਾਂ ਇਕੁਏਸ਼ਨਾਂ ਨੂੰ ਡਿਵਾਈਡ ਕਰਦੇ ਹਾਂ ਡਿਵਾਈਡਿੰਗ ਸੈਕਿੰਡ ਬਾय 1 ਤਾਂ ਆਪਣੇ ਕੋਲ ਕੀ ਆ ਜਾਊਗਾ tan ਥੀਟਾ is equal to QE by mg ਤਾਂ ਆਪਾਂ ਹੁਣ ਇੱਥੇ QE mg ਦੀਆਂ ਵੈਲਿਊਜ਼ ਪੁੱਟ ਕਰਦੇ ਹਾਂ ਤਾਂ ਇਸ ਤੋਂ ਬਾਅਦ ਆਪਣੇ ਕੋਲ ਆਨਸਰ ਹੈ ਜਿਹੜਾ tan ਥੀਟਾ is equal to 2 into 10 raised to power minus 8 into 2 into 10 raised to power 4 divided by मास की वैल्यू अपन को कितनी गिवन है 80 into 10 raised to power minus 6 into जी की वैल्यू मान दें 10 इन्होंने सॉल्व करके जी अपनी सारी वैल्यू आऊ tan थीटा इक्वल टू हाफ के इक्वल आऊ मतलब 0.5 तो हम आप पता जो tan 27 डिग्री होंगे और 1/2 के इक्वल होंगे तो इतों थीटा की वैल्यू कितनी आ गई 27 डिग्री आ गई तो हम आप टेंशन पता करनी सी तो आप टेंशन देख रहे कितनी है T is equal to QE by sin थीटा ये आप कितों लैता है ये आप लैता इक्वेशन नंबर 2 चों इतने आप लिख भी दिने फ्रॉम इक्वेशन 2 तो इतों आप T की वैल्यू फाइंड कर देंगे तो आप इन्हें सॉल्व करके T इक्वल टू Q की वैल्यू कितनी है 2 into 10 raised to power minus 8 E की वैल्यू कितनी है 2 into 10 raised to power 4 थीटा कितना आपको sin 27 डिग्री इन्होंने सॉल्व करके अपने को वैल्यू आऊ 8.8 into 10 raised to power minus 4 वोल्ट ये अपने को टेंशन की वैल्यू आ गई। थैंक यू सॉरी वोल्ट नहीं न्यूटन आऊगा न्यूटन क्योंकि टेंशन एक फोर्स है तो उसकी यूनिट न्यूटन होती है। थैंक यू।
Hello students, the question here is a rigid insulated wire frame in the form of right angle triangle ABC is at a vertical plane as shown in figure. Two beads of equal masses m each and carrying charges q1 and q2 are connected by a cord of length L and can slide without friction on the wires. Considering the case when the beads are stationary, determine the angle alpha, second part, the tension in the cord, third part, the normal reaction on the beads, and then if the cord is now cut, what are the value of the charges for which the beads continue to remain stationary? Here the figure is given to you. So students, it is a question that is a numerical type. There is an insulated frame, and the most important that the frame is in the form of right angle triangle. Frame is in the form of right angle triangle, and then in a vertical plane. Then the two beads of equal masses having a charge Q1 and Q2 are connected by a cord, and the length of the cord is L. Length of the cord is given to us, that is equal to L, which is C from the figure. Now we have to calculate the angle alpha, tension T in the string, normal reaction on the beads also. Okay. So here first we have to use the concept that is Lamy theorem. Just I will tell you about the Lamy theorem first. That what does the Lamy theorem indicates for you? That if there are three forces acting at a point, if there are three forces acting at a point, and let us consider the forces are F1, F2 and F3, and there is angle gamma, alpha and beta. Then as per the Lamy's theorem, it is known that F1 upon sine alpha, opposite angles, F1 upon sine alpha should be equal to F2 upon sine beta, F2 upon sine beta, and F3 equal to F3 upon sine gamma. So it is the Lamy theorem which we use to solve the numerical here. You must know about that theorem. Now, what you have to do here, the first part, that is find the value of alpha. So first, to solve this, we have to draw a figure for you so that all the forces are clear to you. Now the various forces that I will discuss with you, that will acting on a point P and Q where the charge Q1 Q2 are placed. So here I will first draw that figure particularly in a simplified manner. That here is the point P, and at point P the various forces which are acting, that is, first, weight mg will acting vertically downward, and then here is a normal reaction N1. Normal reaction N1 will be there, and here the charges are Q1 and Q2. So if there is a force, that is electrostatic force, which should be equal to the tension T in the string, then regarding that the force here is T minus F can be F, where F is electrostatic force. And here we suppose the various angles, and the figure will be like this. Here I will just extend the line as per the given figure. Now here. Now I will just draw the various angles that we have to consider. That let us suppose this angle be equal to 1, and this angle be equal to 2, and this angle be equal to 3. Now it is also given that this small angle should be equal to alpha. I will just draw like that, and here this small angle should be equal to alpha is given in the figure. Now, if we discuss about the point Q now, here, that is the figure, there is another point Q here. Various forces on Q I will also discuss with you. At various forces on Q. First, the weight will acting vertically downward, mg. Here the normal reaction m2. Similarly, there is a T minus F force should be here. Similarly, I will discuss with you F is the force because of the charge. It's called electrostatic force. And here, as per the figure, these lines can be joined. They line this and this joined with this triangle like this, formation of triangle here. Now, here I will plot an angle for you. Let's consider this angle be equal to A and this angle be equal to C and this angle should be equal to B. Now remember one thing, what's the value of that angle? So quite important for you. What is the value of that angle? That definitely should be equal to, I will write it here for you, that is equal to 90 minus alpha. And this angle must be equal to 30 degree. As figure this angle is also that is equal to this angle is equal to 60 degree. Now, the figure and the forces are very much clear to you now. Now further, I will just simply apply the Lami's theorem. Simply apply the Lami's theorem here by applying Lami's theorem on a point P. What you have to find out here. So the Lami's theorem at point P here, that should be equal to n1 upon angle 1. What is the value of angle 1 here? I will just solve for you on right side. That the value of angle 1. That this angle should be 60 degree. I will also clear to you first. Angle 1. So by using the linear pair, angle 1 plus 60 degree plus alpha should be equal to 180 degree. So from here, angle 1 should be equal to 120 degree minus alpha. So here written as n1 upon sine 120 minus alpha. Sine of 120 degree minus alpha. Which should be equal to mg. The angle opposite to mg is angle 2, and that should be, it is given that I will write in first line that right angle triangle, so that should be, the term is 90. So that angle 2, you particularly solve that angle 2, that should be equal to 90, it's alpha, so it's 90 plus alpha. Sine of 90 plus alpha should be equal to cos of alpha. And then T minus F should be equal to, angle 3 should be equal to 90 plus 60 here, so that is cos of 60 degree. Let us suppose this equation be equal to 1. Now, similarly apply the Lami's theorem on point Q here. Apply Lami's theorem on point Q. Then similarly I will just write down here n2 upon the angle opposite to here is A. And what's the value of A is? I will just solve it here from the right hand side. A, how can you find out A? That is A plus 30 degree. I will also discuss 30 degree. That is A plus 30 plus 90 minus alpha should be equal to 180 degree. From here, A should be equal to alpha plus 60 degree. So clear, n2 by sine of 60 degree plus alpha. Similarly, mg upon it should be equal to sine of 90 plus 30, sine of 90 plus 30, which is equal to cos 30 and also equal to t minus f. Just wait, sine of that angle for mg opposite is sine of, for mg here, the angle C should be equal to, it's 180. The angle C should be equal to, here written as sine of 180 minus alpha. Here we have to written that sine of 180 minus alpha, which should be equal to, student, it should be equal to sine of 180 minus theta is sine theta, so here sine alpha, and t minus f upon sine of 90 plus 30, here written as cos 30. Cos 30, so let it be equal to equation 2. So now we have to form these two equations, equation 1 and equation 2. Now we have to solve the part for this. That first part that we have to find out, students, the value of alpha we have to find out in the first part. Simply, if we rewrite the from equation 1 and 2, it is clear that first from equation 1 we know that mg upon, from equation 1 we know that mg upon cos alpha should be equal to t minus f upon cos 60. That's from 1. And from 2, mg upon sin alpha should be equal to t minus f upon cos 30. Cos of 30 degree. So if we divide 2 by 1, what we got here, that tan alpha should be equal to cos 30 upon cos 60. So that should be equal to tan alpha should be equal to root of 3. So here alpha should be equal to 60 degree. So it is the answer of our, this is the answer of our part first. Now in second part, what we have to find out here, tension in the cord. So for finding tension in the cord, we use any equation. Just we use this equation number, that is here, that t minus f upon cos 60 equal to mg upon cos alpha. So from that equation, from 1, t minus fp, t minus f should be equal to mg cos 60 upon cos alpha. Alpha is also equal to cos alpha. What's the value of alpha is here? Alpha is also 60. So that should be equal to cutoff. So t minus t is equal to mg plus fp. T is equal to mg plus fp. It's the value of tension T. So put the value of Fp here. We find that. So put the value of Fp here. Then T should be equal to mg plus k. Q1, Q2, distance is L. So L square. So it is the value of tension. So we can find out the answer of part 2 here. Now for part 3, what we have to find out here, just see here, part 3, normal reaction in the two beads. So we can find out here, that is N1 and N2. So we have to find out N1 and N2. So we know that from equation here, we know that N1 upon sine of 120 minus alpha, which is from equation 1, should be equal to mg upon cos 60. And 120 alpha is 60 degrees, so N1 should be equal to mg into sine 60 upon cos 60. So N1 comes out to be root 3 mg. So it is the answer of part 3rd subpart, and also for part 3rd we find out the value of N2. I will find on the right hand side. I will simply just make a line here. Now, here find out the value for N2. We know that the equation, that is equation 2nd. From here we clear that N2 should be equal to what? That N2 upon sine 60 plus alpha should be there. So here we written that N2 upon sine 60 plus alpha, alpha is 60 degree. So that is equal to sine 120 degree. Sine 120 here comes out to be upon sine 60 upon the values here we use, that is sine 60 into mg. Now sine 120 should be equal to cos 30. So cos 30 upon sine 60 should be equal to mg. From equation 2nd, that is sine 90 plus 30 is 90 plus 30, so it should be sine 60 here. Here we written that from equation to clear that, here should be sine 90 plus theta cos theta. So here what we write, sine 60. Simply we write for you, that is sine 60. Sine 30, sorry. Simply written that sine of 90 plus 30. That is sine 30. No, sorry, that is cos 30 will be here. As you know that I have written for you also, that remember one thing, the trigonometric ratio, that sine of, I will write for you, sine of 90 plus theta should be equal to what? Cos theta. So here written that cos 30. So here is cos 30. So N2 should be equal to mg. So from here, this is your answer of your part 3rd, that N2 and N1 is solved here. Now at last they is asking for to you, that is, if the cord is now cut, then what are the value of charges for which the beads continue to remain stationary. So if the cord is cut, it is clear that when cord is cut, then tension in the string should be equal to 0. So if T is equal to 0, put the value in force formula. If we put the T should be equal to 0, where in the second part we find out the T, that T should be equal to mg plus q1 q2 upon L square mg. So if T should be equal to 0 here, then mg plus q1 q2 upon L square should be equal to 0. Here k is also, put the value of k is 1.4 pi epsilon naught. I simply written that mg should be equal to, or we find the value of q1 q2 here. So q1 q2 should be equal to minus mg into L square upon k. So I hope it's the right answer of your question. Thank you.